going to be all up at the front for the first couple minutes. Okay. And all right, so I'm sharing even though you can't see it. Plan is to do lessons 9 and 10. It's going to be kind of light lifting as far as the amount of time it will take us. We'll definitely get it done today with some time left over, but the it would have been too hard to squeeze in 11 or part of 11. So we are not going to do that. Let's see here. Guys, phones away, screens off, laptops closed, turning around. Here we go. Again, lesson 9 and 10. We are starting our chapter on traversals, which we'll find out what they are in a second. Well, just go ahead and tell you. It's when you use lists, super long lists, you can't be sure what's in them. And you still may want to, or how many slots are filled, how long the list is. And you want the ability to do something to every item in the list. You loop through the list, and that's called a traversal. Okay, we've already seen a bunch of loop stuff, and we'll see some more stuff. It'll be 4 loops, 4 days. But here, starting with our Traversal Explore first lesson, the link for the video we're about to watch is right here in the calendar, but we are not going, if you're watching the replay, you aren't going to see it because it's going to be up on the other board. But here we go. So let's flip this and this, and we'll go like that. And is this going to work? Ha.
With this, we can begin to store lots of data, and we can also think about writing code to process that data. For example, a list of the pixels in an image can be processed to change their colors to give the image a unique filtered look. A digital song file is actually just a list of waveform samples and can similarly be processed to apply. We know that computers are great at repeating commands in the form of loops. So when we want to process every item in a list in a similar way, we can use a loop to iterate. Let's look at how we use loops to process lists. First, we can make a while loop to run a specific number of times by using a variable called count. This loop will run 6 times. We also know that lists have numbered indexes starting at 0, and since the variable count stores a number, we can use count as our index into the list. And since count changes every time through the loop, starting at 0 and going up by 1 until 5, this gives us a mechanism for accessing every item in a list. An easy first step when processing lists is to write a loop that prints out all the values in the list to make sure you are seeing everything. Let's do that here. We'll add a console.log statement in the loop and make the loop condition more general by removing the hard-coded value 6 and replacing it with the length of the list. Now, if the list size changes, our loop will still print everything out. Let's run it. This kind of looping structure, one that uses a variable to control the number of times the loop iterates, has 3 basic components to it. Creating and initializing a variable to use as a counter, some condition that checks the value of the counter each time through the loop, increasing the value of the counter by a set number for each iteration. This kind of structure is so common that many languages include the for loop to do just that. The for loop combines these components into a single line of code for convenience. The standard setup of a for loop looks like this. There is a lot going on here, but you can see it has the same basic components as the while loop above. It creates a counter variable called I, while I is less than 4. Add 1 to I every time through the loop. You might read a for loop out loud like this. For variable I starting at 0, while I is less than 4, I plus plus. You can think of I as shorthand for index, and I plus plus is shorthand for increase the current value of I by 1. The value of I will come in handy when we use it to access each item of the list, just like we use the counter variable in the while loop. Note that I is just a convention, and you can name it anything you want. Let's look at an example of using a for loop to go through every item in a list and doing something with each item. Here we have a list of red, green, and blue values for a very small image. We could brighten it up by adding 50 to every number in the list. In each iteration of a loop, we are getting the current value stored in the pixel list at index I, adding 50 to that number, and then updating the value at that same slot in the list to the new value. So the first time through the loop, I is 0, pixels at index I, or pixels at 0, is 28. 28 plus 50 is 78. Pixels at index 0 is updated to be 78. The next time through, so 1 will be accessed and updated in the same way. This will happen for each item in the list. With a for loop and a list of values, we have an easy way to process all of the items in a list. This is a foundational concept in computer science you will see over and over again, and it unlocks the power of dealing with lots of data.
All right, go ahead and load up current unit lesson 9, and we'll go through this. We are not sharing there, we're sharing there. Excellent. Okay, so making our way to current unit lesson 9. The only bubble for lesson 9 is a check for understanding for essentially what we just watched. There's a short offline activity that we're not going to do because it's not going to be as useful as the other things. Okay, so why is a traversal with a for loop a good method for accessing, updating items in a lengthy list? Okay, there was at least one portion that addressed that specifically. I'll give you a second to go over it. If you want to wait until we finish lesson 10, you might have a better idea of what's going on. Also, as an aside, if you'd like to join the Zoom meeting to see a little better when we go on here to lesson 10, that's a good thing to do. All right, let's go ahead and jump in to lesson 10, bubble 1. And we've got a couple of investigations to do where we will do a few minor changes, but definitely some explaining. Okay, so on bubble 1, we've got the mile tracker app, which is a great example of an app that I think meets the requirements for the create task coming up. Like, this is the type of complexity that you're looking for. Just have an idea of what's going on. We'll talk obviously about the specific requirements. So we'll just go through this together. you could see, well, when you get here, the app works. It takes a bunch of number inputs and then does some quick math with it and has a text output. Let's see how it works. Okay, so starts out, key is an empty list called mile times, and it's where everything is going to be stored. Okay, I'm sure I've pointed this before, that lists, I think the majority of the time, at least half the time, are initialized empty. It's rare to have a list that you like physically type in the values. The other common situation is where we would start with data, its own data, but there's not going to be a lot of typing in lists. And then we have a bunch of other variables that are just going to be keeping track of the various statistics we're looking for, and one for receiving the input called new time, which for now, new time only is used here, and it's gathered here, but it's only used here. We could technically put that right there and eliminate a step, but we're not going to, because I want to put in a conditional here that will prevent the user from breaking it, which is not included right now. Okay, just playing with the app for a second. Okay, you put in some numbers. If you put in a empty, it breaks it. If you put in a, let's go again. We go again. If you put in a, does it put in letters? Yes. So if you put in any sort of letters, it breaks. Okay, so we're gonna put in a conditional to prevent that. Yeah, so we'll get to that shortly. And so the only event handler in the entire thing is the new mile time button. And that retrieves the text input or the number input with a get number and appends it to the list, and also increases the number of items, or there is a variable here called total miles, and it's completely pointless because it's always going to be the length of the list. So anytime you would need to access miles, you could just use mile times dot length. It doesn't really improve anything, but it's there. We don't really need to change it. Okay, and then it calls update screen, which update screen has 4 of its own functions called, which are all down here: average, slow, fast, and numbered list display, which is the how it actually, of course I put in the thing that breaks it, how it actually presents it with the set text. So what is actually happening? Trying to think what, well, first let's do what the modify actually asks. Okay, we're going to write a function that adds together every list of, or every item in the list, and then, is an update screen. Okay, so this idea of having or totaling up the numbers in a list is pretty common. We are going to need a variable because we're trying to keep track of stuff. Feel free to follow along. This is what we're doing now. Okay, we could just call it total or totes. How about, yeah, let's just go with total. Total. And at the beginning of the app, the total 0. That's fine to start it, initializing it with a 0. And we need a function definition. And just to keep everything orderly, I'm going to put it, well, first I need more white space blocks. And I'm going to put it right below the update screen function so that it keeps the same format that we have. There we go. And let's go like this. All right, so right below the update screen functions where I'm going to do it. If you want to sort of keep yours in line, that's fine. And we need to name this function. let's name it list total, maybe. That's fine. And we are going to call it, make sure it's actually called, and we'll call it here in the update screen function so that it happens every time. And what do we want to do? Well, we want to access every item in a list. So we're going to do a for loop. And the length of the loop is, we want it to happen to every item in the list. So it's going to be list.length. Okay. We are starting to get to the point where we're using dot length as much as we're using dot. How many times do we want to do the loop? We want to do it to every item. So it's going to be mile times dot length. You almost never will put, I can't imagine ever putting a dot length -1 in the for loop number of times. That would do something, do whatever you want, but to whatever you want it to do, it would just do it to all of them except the last one. There is a scenario where you'd want to do that. Like if you were checking every item against the next item, you wouldn't want to do it to the last item because there's not a next item. So that would be a scenario, but almost always, sorry for giving you a valid counter example. But here we are. So mile times dot length, we want to do it to every item. Okay, and what do we want to do? We want mile totals, or total, what do we call it? Total, it needs to increase by whatever item, whatever the value of each item in the list is. So to increase by is the same thing as gets itself plus whatever is in mile times at the index we're looking at, which is I. Okay. Every time through the list, the value of the counting variable I is what we're using to check each of the items in the list. Okay. So our variable for keeping our totaling variable gets whatever it used to be, meaning like the previous time through the loop, plus whatever value is at mile times. Okay. And then our total will be totaled up, and we want to console log the results. We want to console log total, not in quotes. And what do we got here? Total mile times, milt times, mile times. Total gets whatever it used to be plus what the thing we're looking at, and we print. And let's see what happens. Total is 34. Let's go 1. Oh, you know what? It's not going to work because every time we open this, or every time we click on something, total is going to keep continuing. So what we need to do is actually wipe total because it's going to keep its value. If we don't clear out total at the beginning of the function, it will still be holding whatever it had previously. And that's why we're getting cumulative values here. We want to reset total to 0 at the beginning of every loop, which we probably, and again, if I could just spell, I'm having lots of typing issues. We could have just made the entire variable local because it's not used anywhere else, and declaring it here would work. But we don't need to do that. This works fine, or it should work. Let's see what happens. Put in a number. Okay, I go there we go. Okay, so we don't have an output on the screen, but we do have our console log and it is working. Okay, and what was the other thing that we need to do? Yeah, call an update screen. All right, so the extension that we need to do is we need to protect the user from breaking it by the two ways I showed before. One way of breaking it is by having an empty string or having an empty list, which doesn't change our totaling or our like total miles, slow as fastest, but it does ruin the average. And I wonder if it, yeah. So letting them click on it while it's empty breaks it. And the other thing that breaks it is any sort of letters. The first solution is going to be easy to solve because we are just checking to make sure it's not empty. Okay, so, and we're going to do this in sort of a nested situation, so we don't have to worry about ands and ors. We're just going to wrap the entire set of code for new mile button inside of a parameter. I mean, inside of a conditional, an if statement. And what are we checking for? We want to make sure, well, actually, we need to get the value first. Before we can check to see if the user has typed anything in or what they've typed in, we need to get it. And this is the reason why we can't do this sort of one-step thing, is because we need it beforehand. And we want to make sure it's not empty. How do we make sure it's not empty? We are checking if new time does not equal empty string. Okay, does not equals exclamation equal. We are making sure that it's not empty string. Okay, this should at least prevent the one scenario. Oh no, why is it? That shouldn't happen. Did I not refresh it? If new time does not equal, how is that possible? New mile button. Is it because it's a number and it's not counting as a string? How do you... Oh, okay. So here's how we can do it. Instead of checking for an empty string, we can check to see if new time is greater than 0. Right? I think this is going to do both problems. And the reason why is, okay, this doesn't break. That works. And the letters work. No. Okay, so that fixed it. Here is the reason why we don't need to check for an empty string. We are getting it as a number. And if it's empty, it's either null or doesn't exist or something. It's not going to qualify as greater than 0. And that solves the blank problem. And as far as if it's text, okay, we can do a little logic test in a console log. Okay, console log 1 is greater than 0. Just to show you how this works, this console log should say true. Okay, so is a string greater than 0, which sounds ridiculous, but it's going to come up as false, which keeps the loop from running. Okay, what about an empty string? Does an empty string return as false? Is an empty string? Yep. Okay, so both of our problems, empty string and letters, return false. So that breaks it. It also keeps the user from typing in negative numbers, which, what would happen? Let's hold on. Let's just see here. What happens? This is essentially putting it back the way it was. It does let you put in negative numbers the way you get it, but we don't want it to. Okay, so all we need to do is check to see if the input is greater than 0. And since letters, and actually we can check this out for sort of just to learn how the computer's taking logic. So we are saying, is our character greater than 0? We run it, that should say false. What about if we say is a string less than 0? Okay, is AFDF less than 0? It is also not less than 0. What about if we do double equals 0? Okay, so if you put a string in any sort of numbered comparison, like greater than 0 or less than 0, it's going to come out false, and that's how we are checking to make sure that it's not a string if they were putting in. So that's blocking it. And because we chose greater than 0, it will only take positive. You can sort of, another way to double check that it's a number, you could say if new time is greater than 0 or new time is less than or equal to 0, do the thing which any number would qualify as true here. Every single number is either greater than 0 or less than or equal to 0. And that would solve the problem of just checking to see if it's a number. But the way we are going to leave it, we'll check to make sure it's a positive number. And I think that's it for this one. Okay, and let's do bubble 2. We get a look at the use of the data tab, the built-in data tables, which we've already have the dog table loaded up. And you can see it's quite extensive. And how many pages are on it? Is it just the first page? There are some lists, like the Netflix list has thousands of entries. But let's see what we have here. Does this work as it runs? It does work. It's super slow though, because that is not a pit bull. There we go. I don't know why. Is it App Lab or the Wi-Fi that's going super slow? Or just some redundant programming. Either way, what do we have here? This is a filtering app that we will see a lot of, and it's actually part of the project is starting with a long list, like the data lists from the table, which arms, starting with a huge list, go through the entire list and check each item in the list for some quality, for some characteristic, and keeping it if it's true, or keeping track of the ones that satisfy whatever characteristic and then presenting them. And that's what's happening here. We are starting out by getting 3 of the lists, which are columns. Okay, columns behave like lists, and because they are the same length, each index, whatever's in the 10th index of names corresponds to whatever's in the 10th index of height and whatever's in the 10th index of images. So that's how we are accessing a row. Okay, at index 10, we have that animal, that height, and an image for it. Okay, and then we have 2 other lists, the filtered lists, which start as empty, and that is where we will end up appending items to that satisfy whatever requirement we're looking for. And there's only one input, and it's the size dropdown, and it calls our setup function. Okay, list setup. List setup is this function down here, which it only calls filter and update screen, which means these 2 things could have been, I don't know, it doesn't save that much to have a function called list setup. But the two that we have, filter and then update screen, filter goes through the entire list. Well, let's see what filter does. Filter starts by clearing the list. Okay, that's important. Otherwise, it will be cumulative, which is not what we want. And then it gets the user's input, which is the user's input is from one of the three possibilities for dropdown. And because it's a dropdown, we know what to compare it against when we get to our conditional. We don't have to worry about the user doing case sensitivity or spelling or something like that. We know what their possible inputs are. There's only three of them. And once we have that, we are going to go through the entire list of dogs and check for things. Okay, it's saying dog height dot length, but we could use any one of the lists. And dog height is the only thing that we're checking. When we are checking the heights, we are gathering the other two pieces of information that we need from the other lists at that same position. Okay, might sound like a lot, but we are doing this for each item in the list. So item through when I is 0, we are checking to see if the height of whatever's in index 0, or the number technically that's in index 0, is less than 16, and the user has input small. If they have, that means that whatever's in the height list matches the user's input, and those are the ones we want to keep. Okay, if this first, compound conditional is true, the filtered list will be populated with all the names and images of the dogs that are less than 16 in height. Okay, the next one we're checking to see if that's false. When we go to each one, we are checking to see this height range along with the user's input. So I actually would probably set this up with the dog size conditional on the other side, or the user's input conditional on the other side, because I think it makes more sense if the way that it's written out, you don't need to change this, but the way that it's written out looks like this, and it should be the same, where we're saying else if dog size, which is the user's input, is medium, and it's these other things, it's a medium dog, we want to keep it that time through. Okay, so each time through, or each time the app runs, it's comparing the user's input to each height, to the height of each dog breed. And if the one the user chose, if the number from the list matches whatever range we're looking at, and it matches what the user put in, we want the name from the index in the names list, and the image from that index in the image list. This is a lot, and if you haven't visualized this stuff before, seen it before, it's probably difficult to keep track of things, what's happening in your head. Hopefully you get to the point where you can just sort of work through the code by looking at it and see what is happening, behind the scenes. And so every time the user changes it, the list is wiped. It goes through the entire list, checking heights and the user's input. And if on that index you get a match, we're keeping the names and images from that same index. Okay, there's a console log, which is just the user's. Do we console logging the entire list? Yeah, okay. So the console log is printing out the entire list of dog names that match the user's input. Dog size, again, is the user's input. I'd probably call it user or dog size input, something like that, so it's a little more clear. And then the update screen function is what's setting the screen, but it's doing what we've done before, where it's picking an item from the list at random, or rather picking an index of the filtered list at random and using the name and picture from that filtered list each time. And we can see here, let's so by the time it gets to here, the filtered list will be full. Let's console log, and just at this point, just learning. Console log filtered, what is it? Filtered dog names dot length, just to see how many are in there. So we hit run, and there are 25 that match the requirement of being under 16 because the choice is small. If the choice is medium, there are 27 dogs that have a height of between 16 and 24. Because we've selected medium, any of the dogs that have a height between 16 or 24 count as medium. And if we did large, there are 53 dogs that count as large. If the large and the dog height is greater than 24, those are the indexes or the items at those indexes that get added. Okay, so maybe that lets you see a little bit behind the scenes of what's happening. Data tag, columns, apps, look at the filter function, what condition is checked to determine elements being filtered. Yeah, so that's about it. Let's take a look at the bubbles 3 and 4. They are the square, tilted square with not much as far as deliverables go. Okay, so basic filtering pattern. We have a list of things and an empty list, and then the filter function goes through the entire list, checks for some condition from the item in the full list, and if it matches, the filtered list gets that item. So the filtered list will be reduced to the things that match the requirement. Okay, and same thing here. Filtering multiple list works the same way, which is what we're going to do, which is what just happened. We were filtering based on dog height and user input. We were filtering down full list dog names and dog images. So we were already doing multi-list filtering on the last bubble. Okay, and then bubble 4, square 4, reduce is the same basic idea where we are, like here, finding an average or finding the smallest. This is about keeping track of, for longest and smallest, I'm disappointed they didn't, we don't go through it as much, but that's what's happening here with the slow and fast functions from bubble 1, where it's keeping track, it's using the first one as a standard and then comparing it to the next one. If the next one is larger, which is fast means, or I guess slow means larger. If the next one is larger, it replaces the one it's storing with the next one, otherwise it moves on. And so by the end, you have your sort of running champion that stays as the highest number, which is what's happening here. We're just going through the list and keeping track of whichever the biggest one is, or in this case, the smallest. And the last deliverable here is the check for understanding. Explain how you would filter the dog data set using Traversal to have filtered list of dogs who have long lives. You can use the example as a starting point. Would be this, except for, and so on. You don't need to like describe the entire app. The entire hypothetical app. Okay, so that is it for today. Please make sure you get it done. Okay. All right.